The 2026 Formula One cars represent one of the biggest regulatory overhauls in the modern era of the sport, combining major changes in aerodynamics, power units, energy recovery, safety concepts, team strategy, chassis design, and overall racing philosophy to produce cars that are smaller, lighter, more agile, more energy efficient, and more reliant on hybrid electric power than any F1 car that has come before, with the primary goal of creating closer racing, reducing aerodynamic disturbance, increasing manufacturer interest, and pushing Formula One toward its sustainability objectives, all while ensuring the spectacle remains exciting and technologically relevant. In this new era, the cars shrink from the large, heavy designs of the 2022 to 2025 rules to a more compact shape, with wheelbase reduced from 3,600 mm to around 3,400 mm and overall width reduced from 2,000 mm to 1,900 mm, which, combined with narrower tires, 25 mm less at the front and 30 mm less at the rear, produces a more nimble car that rotates better through corners and is less dependent on large, drag-heavy aerodynamic surfaces, while the minimum weight reduction of around 30 kilograms helps offset the increased mass of the hybrid system, delivering a car that feels lighter on its feet and more responsive. Meanwhile, aerodynamically, 2026 introduces a revolutionary active aero system that replaces the traditional DRS flap with a far more comprehensive approach, allowing both the front and rear wings to switch between a high downforce Z mode for maximum grip in corners and a low drag X mode for straight-line speed, creating a new dynamic style of racing in which drivers adjust aero settings frequently throughout a lap, which changes not only how overtaking is performed, but also how drivers defend, manage their tires, and approach racecraft as a whole. Especially now that the new rear wing concept eliminates both the beam wing and conventional DRS slot in favor of a multi-element active surface designed to reduce drag by approximately 55% compared to current cars, while downforce overall falls by about 30% to lessen wake turbulence and allow cars to follow more closely. The underfloor is also redesigned with a reduced floor width and less aggressive ground effect tunnels, reducing the dependency on extremely low ride heights and minimizing the porpoising issues that plagued the early 2022 ground effect era. And the front wing becomes narrower and simpler, while the wheel arches trialed in 2022 are abandoned in favor of lighter, sleeker wheel bodywork elements that minimize turbulence without adding complexity. At the same time, the power unit becomes significantly more hybrid-oriented, maintaining the familiar 1.6-liter turbocharged V6 ICE, but shifting the balance of power dramatically by eliminating the MGUH, increasing electric motor output from 120 kilowatts to a massive 350 kilowatts, and doubling the amount of energy that can be harvested per lap to 8.5 MJ, fundamentally changing how drivers deploy energy, plan overtakes, defend positions, and manage battery charge, because in 2026 the electric motor alone can provide nearly 470 horsepower, meaning the hybrid unit is no longer a small part of the total power but almost half of it, allowing the car to rely heavily on electric boost during acceleration and overtaking. Fuel technology also shifts completely as Formula One moves to fully sustainable synthetic or bio-derived fuels that burn cleaner and help the sport reach its net zero carbon goals, which not only impacts on-track performance, but also aligns F1 more closely with future road car development, attracting major manufacturers like Audi and encouraging others to stay in the championship. Racing itself will change dramatically because acceleration, defending, slipstreaming, and overtaking will no longer depend solely on downforce and DRS, but instead on a blend of energy deployment strategy, active aero timing, and efficient harvesting underbraking, as cars gain a new manual override mode or electric boost system that replaces DRS entirely, giving trailing drivers extra electrical power when close enough to the car ahead, reshaping the nature of wheel-to-wheel battles and forcing teams to rethink how they simulate race strategy, energy budgets, and tire life, especially because insufficient battery harvest can leave a car vulnerable or unable to mount an overtake. Meanwhile, engineers face massive challenges because the removal of the MGUH increases turbo lag, and teams must find ways to balance combustion efficiency with battery requirements, cooling demands, and weight distribution, all while staying within cost cap regulations, making the 2026 rules a monumental engineering puzzle that has already caused apprehension among technical directors and aerodynamicists who worry that meeting performance targets, energy constraints, and safety standards simultaneously will be extremely difficult. But despite these concerns, the FIA and F1 leadership believe the new rules will produce more exciting racing by reducing the dominance of aerodynamics, increasing driver skill influence, and promoting active decision-making, with smaller cars opening up more racing lines and less dirty air improving followability through medium-speed corners, potentially reducing the train effects created by strong DRS zones in previous seasons. Additionally, safety remains a priority as new crash structure standards, improved battery fire containment, and redesigned chassis composition ensure the cars remain among the safest racing machines in the world. Despite their increased reliance on high-voltage energy systems, in terms of visual appearance, fans can expect cars that look sleeker and more futuristic, featuring thinner wings, movable aero elements, slightly smaller bodywork, compact sidepods optimized for hybrid cooling, and possibly more aggressive rear-end packaging due to reduced exhaust integration. Strategically, the racing may become more complex but also more unpredictable, as the outcome of battles may hinge on how effectively a driver harvests energy into the battery through braking zones when they choose to engage low-drag X mode, how they anticipate their rivals' energy levels, and how efficiently they balance hybrid deployment across a lap, meaning races could feature more strategic overtakes, unexpected pace swings, and late-race shifts in competitiveness. Overall, the 2026 Formula One cars symbolize a shift toward a more ethical, technologically advanced, and road-relevant future, merging sustainability with high-performance engineering, pushing the hybrid envelope further than any motorsport series has ever done, and aiming to deliver more dynamic, engaging racing where driver skill, energy management, and aero mode timing play bigger roles than simply relying on massive downforce, endless grip, and DRS-assisted passes, making the 2026 rule set not just a technical update, but redefinition of how Formula One imagines its next decade.